warm greetings to all our viewers. In the modern world, we humans are completely surrounded by electromagnetic radiations. Have you ever thought of physics behind these traveling electromagnetic radiations? The great physicist Heinrich Hertz was the first to produce and detect electromagnetic waves. But, as you already know, before Hertz, Maxwell had already laid the foundation of these waves in his famous equations that we did in the last program. The electromagnetic spectrum is the range of all types of electromagnetic radiations. But what is a radiation? Radiation is energy that travels and spreads out as it goes. The visible light that comes from a lamp in your house and the radio waves that come from a radio station are two types of electromagnetic radiation. The other types of EM radiation that mark up the electromagnetic spectrum are microwave, infrared radiations, ultraviolet rays, X-rays and gamma rays. What is the wavelength of these components? How were they discovered? And what are their uses? So, let's try to answer these questions. In today's program, we are going to discuss the spectrum at length. So, let's begin. On what basis do we classify these waves? Yes, they may be classified on the basis of how they are produced and detected. But there is still no sharp boundary that can be drawn between any two types of waves. In the figure, you can see their arrangement on the basis of decreasing wavelength. So, first comes the radio waves, then microwaves and infrared, visible light, ultraviolet, X-rays and gamma rays and so on. We are going to start our discussion with the first, that is radio waves. On your screen, a picture of Heinrich Hertz is displayed. Hertz devoted all of his time and energy in designing a special setup for his experiments. And later, he was able to prove that equations of Maxwell are indeed correct and he could produce radio waves. So, now we know that radio waves were for the first time produced by Hertz, but how? In his experimental setup, on one side of a long table, he had an oscillator generating electrical currents and a spark or an ignition. A few yards away, he set up a receiver or an antenna made from copper wire bent into a circle. At the ends of the circle were small knobs separated by a tiny gap. He wanted to test if the sparks generated by the oscillator would travel to the antenna and create a spark there, and where? In that tiny gap. And when the ignition takes place, here Hertz noticed that in this antenna you would find an ignition and it a hundredths of a millimeter. So, you can't see it very clearly. So, he had to darken the room and then he had a microscope to look at this point and to notice whether there was ignition or not. The spark generated on one side propagates an electromagnetic wave which travels through the room to the antenna, and a quick spark is seen when generating voltage is high enough. Hertz was the first to detect this spark in the antenna. At the end of 1888, he wrote a famous paper demonstrating that Maxwell was right. Electromagnetic waves aren't infinitely fast, but they travel at the speed of light. The wavelength of radio waves is greater than 0.1 meter. Moving on next, we have the uses of radio waves. As in the figure also, you may see that radio waves are almost used everywhere like televisions, communication system, internet, etc. These waves are used in mobile phones to transmit the voice from the transmitter to the receiver. Our viewers should look for the uses of these waves around them and make a list of it. The next category of waves is microwave. The discovery of these waves was a serendipity. So let's have a look at that interesting anecdote. Microwaves were accidentally discovered by Dr. Percy Spencer in the year 1945. One day, while standing near a magnetron, he realized that the peanut cluster bar in his pocket started to melt and it got quite warm. Then, he put 2 and 2 together and he decided to get some popcorn. So, he sent the popcorn in and it started popping all over the place. The next morning, he brought an egg, and one of the engineers who was a little disbelieving in terms of microwave's ability to cook, just as he was looking over, the egg blew up in his face. So this way, microwaves were discovered and a patent was registered in their name. The early microwave oven was as large as a refrigerator, would take 20 minutes to warm up before you could cook anything. But they were 10 times more powerful than anything you can buy today. So, a potato was cooked in 30 seconds. Microwaves are produced by special vacuum tubes such as klystrons, magnetrons and gun diodes. In the figure, you can see the first ever microwave which was over 300 kilogram and size of a refrigerator. The patent for this discovery was applied and granted on 8th October 1945. The name of the first microwave oven was radar range. Microwaves have a wide range starting from the radar systems to kitchen in cooking and heating up of food items. Viewers should look for more uses of these waves in their daily life. How does the modern day microwave oven look like? You must have seen them in your kitchens. So let's have a look at them. The microwave oven look like the ones shown in the figure. You may heat your food items, make tea or coffee, bake delicious muffins and cakes and many more food items. But how does this happen? That is, how can a microwave bake a cake or heat up our food? Let's answer this in the next slide. In a microwave, our objective is to cook food or warm it up. All food items such as fruit, vegetables, meat, cereals, etc. all contain water as a constituent. Now, what does it mean when we say that a certain object has become warmer? When the temperature of a body rises, the energy of the random motion of the atoms and molecules increases, and the molecules travel or vibrate or rotate with higher energies. The frequency of rotation of water molecules is about 2.45 gigahertz. If water receives microwaves of this frequency, its molecule will absorb this radiation, which is equivalent to heating up water. These molecules share their energy with the neighboring food molecules and thus heating the food up. The basic principle of a microwave oven is to generate microwave radiation of appropriate frequency in the working space of the oven where we keep our food. This way, energy is not wasted in heating up the vessel. I again have a question for our viewers. Can we use metal utensils in a microwave oven? The food that we keep in the oven is heated, but the vessel is not that hot as the food is. But why so? You should look for the possible explanations of these questions. Let's move further in the program and study about infrared rays. In the picture, you can see the photo of William Herschel, who is given the credit of discovery of infrared waves. Infrared waves are produced by hot bodies and molecules. Sun is the dominant source of infrared waves on the earth. Other examples are a room heater, geyser, an iron, etc. But can you see these waves? No. These waves cannot be seen by human eyes as their wavelength doesn't lie in the visible range. Do you know that our sun produces more yellow light than any other color because its surface temperature is 5500 degrees Celsius. So now let's have a look at the various uses of these waves. Infrared lamps are used in physical therapy. Infrared detectors are used in Earth satellites both for military purposes and to observe the growth of crops in agriculture. Let's see some more uses in the next slide. Electronic devices emit infrared waves and are widely used in the remote switches of household electronic systems. This radiation is trapped by greenhouse gases such as carbon dioxide and water vapor. We will now study the most important part of the spectrum, which is the visible rays. We can see a very famous scientist of his era. He is given the credit of studying the visible rays in detail. He is Sir Isaac Newton. Do you know why some of the scientists used to wear this kind of wig? Well, it is related to the title of Sir. Viewers should try and find out. This is the most obvious part of the spectrum, and we can see the world around us due to these rays only. Cone-shaped cells in our eyes act as receivers tuned to the wavelengths in this narrow band of spectrum. Visible light emitted or reflected from objects around us provides us information about the world. And do you know what is the main source of visible light in the environment? Sun is the most important source for visible light waves which our eyes receive. Well, the uses of visible rays are very obvious. You can't see anything without these rays. If you can't see, you can't do many things. Few uses of visible rays are: it is the part of the spectrum that is detected by the human eye, and the wavelength of these rays lie between 400 nanometer to 700 nanometer. Do all the animals also have the same visible range? Well, different animals are sensitive to different range of wavelengths. For example, snakes can detect infrared waves, and the visible of many insects extend well into the ultraviolet range. Other uses are in laser altimetry, and it is an example of active remote sensing using visible light. Let's move on to the next part, which are ultraviolet rays. Ultraviolet rays were discovered by John Wilhelm Ritter in 1801 when he noticed that invisible light beyond the optical region of electromagnetic spectrum darkened silver chloride. Ultraviolet radiation used to be called as chemical rays, and this was because UV could make certain substances change chemically. Many insects, however, are able to see the ultraviolet radiations. Ultraviolet radiation is produced by high temperature surfaces such as the sun in a continuous spectrum and by atomic excitation in a gaseous discharge tube. Ultraviolet radiation are also produced by special lamps. UV radiation is undetectable by the human eye. Now, let's look at how these rays are useful to us. As in the slide displayed, UV rays are used to sterilize and disinfect in hospitals and highly sensitive laboratories. There are many things that are not visible by human eyes but can be seen in UV light. In astronomy labs, there are UV telescopes to see images of various celestial objects. On your screen, you can see two images taken in UV light. You must have seen the UV imaging in various dance shows also. Our viewers should look for such programs and see the beauty of UV photography and videography. Let's see some more uses. When UV rays falls on certain materials, it may cause them fluorescence, that is, emit electromagnetic radiation of lower energy such as visible light. UV rays are also used in lamps. Two images are visible on your screen which depicts fluorescence and lighting. You may find many such examples of UV rays in your daily life. Explore them. On your screen, you can see a welder with a helmet. But why do the welders need to wear this helmet? Welders wear special glass goggles or face mask with glass windows to protect their eyes from large amount of UV produced by welding arcs. After knowing ultraviolet rays in detail, we will now move on to the next part, which is X-rays. X-rays were accidentally discovered by W.C. Roentgen in the year 1895 while testing whether cathode rays could pass through the glass. He later went on to receive the prestigious Nobel Prize for his discovery in the year 1901. To generate X-rays, bombard a metal target by high energy electrons. X-ray tubes or inner shell electrons are also used to produce X-rays. Wavelength range of X-rays lie between 10 raised to the power minus 8 to 10 raised to the power minus 13 meter. But how did the first X-ray machine look like? Let's see that in the next slide. On your screen, you are watching the first ever X-ray imaging machine. These are some modern day X-ray radiography machines. Let's look at some more uses of these rays, mainly used in medical field to see a broken bone or a chest diagnosis, etc. X-rays are used in industries and to check baggage at airports. X-rays are also used in X-ray diffraction and X-ray crystallography. You must have seen them at metro trains, railway trains and many other screening spots also. The X-ray images looks like this as seen on your screen. I am sure that you must have encountered these images while entering the metro, and the second image is of an X-ray of hand to diagnose any kind of fracture. Moving on next, we are at the last part of the electromagnetic spectrum, which are gamma rays. These rays were discovered by Paul Villard in the year 1900. These were the third component of radioactivity after alpha and beta rays. Let's understand how these rays are produced. The gamma rays are produced by the hottest and the most energetic objects in the universe, such as neutron stars and pulsars, supernova explosions, and regions around black holes. On Earth, gamma waves are generated by nuclear explosions, lightning, and the activity of radioactive decay. What are the uses of these gamma rays? Let's find out in the next slide. Gamma rays are used mainly in the medical field, radiotherapy, In oncology, gamma rays are used to kill cancerous cells. They are also used to sterilize medical equipments. Gamma rays pass through plastics and kill bacteria by breaking the covalent bonds of bacterial DNA. Scientists can use gamma rays to produce the element on other planets. With this, we have come to the end of this program. In today's program, we discussed the various components of electromagnetic spectrum in detail. Our viewers should try to look for some more facts about the EM waves. With this, I'll take your leave. Happy learnings and thank you.